Hey math geeks, this is problem number 7 from section 3.1. This is a little bit trickier because we're starting to really have to think. Right, that synthetic substitution thing is just kind of like a little process. You just go through it. But now we start to apply it to like really understanding the problem better. So here's number 7. And we start with this polynomial, 2x cubed, 3x squared, 5x, and 4. First thing I'm going to look at, I look at my powers. None of them are missing. I got my 3 to my 2 to my 1 and then my constant, so that's cool. So the problem starts with find a y for each x that's an element of this set. In other words, plug negative 3 in, plug negative 2 in, plug negative 1 in, and so on, and find all the y's. So set it up with your synthetic substitution. Don't be tempted to just plug that in there and do all that math. It's easier to do it this way, except for maybe 0. I mean, 0 is pretty straightforward. You could plug 0 in and get y right away. So I'm going to set it up. I'm going to take the negative 3. I'll start with this one. And then I'm going to bring down the coefficient, the leading coefficient here for each one. Start with the 2, the 3, the negative 5, and the constant is negative 4. Draw your line, drop that one down, and then you begin the process multiplying. Negative 3 times 2 is negative 6. 3 and negative 6, just combine those two. Negative 3. Negative 3 times negative 3 is positive 9. Combine those two, get 4. You guys are checking my math. Negative 3 times 4 is negative 12. Negative 16. So, in other words, when x is negative 3, if you were to plug it in and do all that math, this is presumably a shorter way of doing that, and you get y is negative 16. So, hopefully you're pretty good with that part. I'm going to continue and do that with all those numbers. And over here, my lovely assistant, Clyde, already did it all, right? Or somebody did this. So we have all the answers. There's negative 3, negative 16, and so on. That part's done, part 1. Now, part 2, they want us to start to, let's see, what's the problem say? How many times does it cross the x-axis? All right, so we have to start to look and think about this, visualize this. I'm going to draw a rough sketch to help with this. So when x is negative 3, way over here, y is way down here, right? Just estimate that. When x is negative 2, look what happened. Y jumped up to positive 2. So I know this graph somehow, it jumped across the x-axis between those 2 points. It has to. I mean, I guess in theory it could have jumped a couple times, but I know it jumped at least once across there to get there. So I'm going to kind of sketch my graph. It's going to be coming down low and it's going to be going up. And then negative 1, it's also at 2. Now, you may be tempted to say, well, maybe this graph went up and then it went over. But if you remember from yesterday, polynomials always curve smoothly. They cannot do straight out lines. So that tells you there had to be a turning point. This graph had to come up a little bit and then it had to curve and come back down. Because the nature of polynomials, they always have smooth curves. Remember that. And then negative 1 and 2, we did that one. Then 0 and 4 and negative 4. So 0 and negative 4. So once again, it crossed the x-axis some point here. It's going to cross it again here. And at 1, it's the same situation. It's negative 4 again. So we can't draw it straight. It's going to be a little curve, and it's going to turn. So it's a turning point. That's what you're looking for. You're looking for turning points, and you're looking for when it crosses the axis. Remember, that's what we're called roots. And that's going to, I think, be the next section where you're going to actually solve for the roots. Here we're just sketching them, getting a feel for where they are approximately, somewhere in between those 2 points. And then finally, you've got 2 and 14, and then 3 and 62. So at 2, you're way up here, and at 3, you're way up here. So now it's going to go up to infinity. So there's a nice little sketch, and that's the third part of the problem. Sketch it. It's going to cross the x-axis at 3 points. So there's 3 solutions. And, oh, by the way, it's a third-order polynomial. So it's good that there's 3 real solutions. We'd actually be able to find these solutions. What happens when y is 0? You're going to have 3 different values for x. And then finally we have a nice little rough sketch showing it. The end behavior here is going to keep going down to infinity. The end behavior on the right side is going to be going up. And just think to yourself what you learned yesterday. Does that make sense that a polynomial that has a positive leading coefficient, that's a third order, an odd polynomial, does it make sense that it should be going down on the left and up on the right? You think about that. Makes sense to me because I can see it. But think about why it does that. Review your notes from yesterday. So that's problem number 7. What you want to do is do it on your own now without the video. And hopefully it'll work out fine. And number 8, I think, is the same style of problem. So hopefully this will help you enjoy it, have fun with it, and namaste.